All right. Over the years in algebra, you guys have learned about systems of equations and solving systems of equations. This was actually supposed to be our warm-up that I just skipped today. You probably would have attacked this using elimination. You remember elimination? We'd like get one of our variables to be the same, so we'd have to multiply both of our equations all the way through, add the like terms, all of that. There is a matrix option of how to solve systems of equations, and that's what we're going to look at today. So back in algebra, you learned about graphing, you learned about elimination, you learned about substitution, and now we're going to learn a fourth option of how to solve a system, and that is through what's called augmented matrices. Okay. So an augmented matrix, first of all, is going to take our system of equations like you see up on the board and translate it into what's called an augmented matrix. Why called augmented? Because there's a divider in here separating our coefficients of our variables. As you see here, 3, 1, 2 matches with the 3, 1, 2 here. So on, 1, 1, 2, 1, 1, 2, 1, 3, 2, 1, 3, 2. And then the constants on the other side are separated, augmented from the rest of our matrix. And it represents our system, okay? So one of the things we're going to do is just be able to take a system of equations and write an augmented matrix, okay? So if I were to hand you this system, how would we create our augmented matrix? Well, one of the things you have to be on the lookout for is missing terms. Okay, so I gave us one missing term in this example, but as I set this up, we need to be cautious that I don't just start throwing the numbers in there that I see, but like this first column would represent the coefficients of my x's, my second column would represent the coefficients of my y's, my third column will represent the coefficients of my z's, and then my last column will be the constant that's on the other side of my equation. But if I'm missing something, what's the coefficient? 0. So in this first equation, we don't have an x, and so its coefficient is 0. And we need that 0 in there, okay? The coefficient on our y is a 2. The coefficient on our z is a -1. And our constant is a 7. Okay, any questions so far? And then we just do that for each of the equations. Coefficient is a 1, 2, 1. Constant is a 17. And 2, -3, 2, and our coefficient is a 1. Now this can be expanded or shrunk down to any size of system, like that 2x2 system that we saw at the beginning with 2 variables and 2 equations. Then you would only have like this much. If I were to cover that up, you would just have this much right here, and that's fine. It can be expanded to 4 variable systems if we had that. And so that's kind of the nice part about it, is it can expand or condense as much as we need it to match our size of system. The next thing we're going to go through is there are 3 different matrix operations in which we can adjust what we are looking at in our matrix to help us move towards this thing that we're going to talk about here in a few minutes, which is called our row echelon form, is how we solve a system using a matrix. But we're just going to look at the operations. Operation 1 would be to exchange any 2 rows. This is kind of the notation. When it has like row and then a little subscript, it's referring to, so like this would be called row 1. This would be called row 2, and this would be called row 3. And the entire row all the way to the constant will do whatever we are saying we are doing. In this one, it says to exchange row 1 and row 2, which is just going to take row 1 and row 2 and flip-flop the order, which does not seem to be overly productive right now, as we don't really know where we're heading, but it can be very productive to us here in a few minutes. So what I like to do is the one that does not change, which in this case would be row 3. I just kind of go in there and put that in because nothing's happening to that. And now I'm going to take row 1 and row 2 and just exchange the 2 of them. So row 1 becomes row 2. And row 2 becomes row 1. And these row operations keep your matrix equivalent. So nothing has changed. All we did was basically write one equation over the other one, but our system is still the same. Okay. A second matrix operation that can happen is we can take any row and multiply it by a scalar. Very similar to what you would have done at the beginning when you were doing your solving your system by elimination, is that you would have multiplied one of your equations by a number. We can do that here. So again, this tells us what we're doing. We're going to take 1/3 times row 1. So what is not changing is rows 2 and 3. Copy carefully. What is changing is row 1. And what we're going to do is we're going to take 1/3 times each of the values. Now, what I'm showing right here is not necessary, but sometimes helpful for people to see, is like physically going in and multiplying each one by 1/3. And ultimately our result would be basically dividing each of those by 3, which would be a 1, 6, -4, and 7. Okay, questions? The third operation that can happen is that you can add a multiple of a row to any other row. And a multiple can be a positive or a negative number. Okay, so like this, we have a +2 times row 2, and we're going to add that to row 3. This can be a little confusing as to what's changing. We are adding it to row 3, which means row 3 is ultimately going to be the one that changes because we're adding 2 times row 2 to that. So the two rows that are not changing would be 1 and 2. And row 3 is going to change. It's going to be what was there, 2 times row 2 plus what was in row 3. Let's see, I should have given myself a little more room here. Let me give myself a little more room here. Okay, 2 times row 2, there's row 2, plus what was already in row 3, 2 times row 2, plus what was already in row 3, 2 times row 2, plus what was already in row 3, 2 times row 2, plus what was in row 3. So you can see row 2 is showing up right here. I'm taking 2 times that number and adding it to what was in row 3. Again, this part does not necessarily need to be shown. It's the result that we're looking for. So now I'm just going to clean those up. 2 times 1 is 2, plus -2 is 0. 2 times 2 is 4, plus -3 is 1. 2 times -3 is -6, plus 4 would be -2. 2 times 5 is 10, plus -6 would be 4. Questions? Okay, those 3 operations we are going to go back to over and over, and which one can help us accomplish our ultimate goal for each of these steps. And these steps are definitely things that I need you to make sure that you are sitting out next to you as we are heading towards this thing called row echelon form. In row echelon form, what you have is, starting in the upper left element, a 1. And then you have a diagonal of 1s heading down across your matrix. Below that diagonal of 1s will be all 0s. Okay, good so far? Now, the order of what we need to do to get this accomplished, if you follow this order, is very helpful. If you don't, it can be a challenging task to get through this. So this page right here is what we are going to go back to over and over and over as we are working through this row echelon form until it becomes more like intuitive to you. I would just make yourself walk through these 5 steps. Step 1 is you want to get a 1 in the upper left-hand corner. Now there's pretty much 2 different ways that I would do this. Either exchange it for something that already happens to have a 1 in that spot, or multiply by the reciprocal of what's here. Okay, those are kind of the 2 ways that I would attack that job. Step 2 is then once we have a 1 here, we'll focus on these 2 spots. And I'll get a 0 here and I'll get a 0 here. How do I do that? I do it by adding a multiple of row 1 to those subsequent rows. Usually at 2 steps there, okay? Step 3, once I have gotten zeros, so we focus on that first column. And then I go to the second column and I kind of repeat that idea. I get a 1 here, usually by multiplying by the reciprocal of that term that's currently sitting in that spot here. And then again, similarly, is I get a 0 to finish out that column, usually by adding a multiple of that row to row 3. And then finally, get a 1 here, again, by multiplying by a reciprocal of the number that's sitting there. When we have this in row echelon form, we will then take our matrix and go back to a system and back substitute to solve the rest of the system, because your last line will say 1z equals a number. So that line is already solved for it. Then we just plug it in and we plug those 2 answers into the top one. I'll show you what that means here. We are doing 1 example today, okay? You guys have a total of 4 problems on your worksheet today. Because you have to go slow and you have to make sure you don't make mistakes, and they take a little bit of time. So I'm not asking you to do a lot, I'm asking you to do them really good. I think that was really bad English. I'm not an English teacher. Don't tell on me, okay? But here's our 1 example. Take good notes. I don't know where this is in your notes. We don't have it at all, anywhere? Yeah, haha. I forgot. I gave you a supplemental page because I wanted you to have plenty of room to work this out. Thank you for finding that. Got to remember what I did. Other page. Other page. There's a 4 variable system. That's tomorrow's notes. We'll get there. All right. The first job is to just take your system and translate it into a augmented matrix. Guys, I can't stress this enough. Go back and double check your numbers. You miss one little negative and you are going to be pulling your hair out. Take your time on this, double check your numbers. Maybe utilize your calculator to double check that you don't do 2 times 3 and get 5, okay? All right, so let's go back to our steps. Step number 1 says we want to get this right here to be 1, okay? There are 2 methods to do that. I could decide to just multiply this row by 1/2. Yes, okay. Now here, I'm gonna tell you why I would pick not to do that, because it would end up giving me a fraction. If it would not give me a fraction, I would absolutely take that option. But because that would give me a fraction here, I don't really like fractions in there. I'm gonna avoid that. So another option is I can exchange it for any other row. Well, both of these already have a 1 built in as that first term. Pick one of those 2 and switch them. Okay, so what I could do is just maybe switch row 1 with row 2. Okay, and here's my result. If I switch row 1 and row 2, I now have a 2, 1, 2, 18, 1, 2, 9. Guys, please stop me if I make a mistake up here. I do not want to continue with that. Make sure we're always matching. All right, Okay, job 1 is done. Go to step 2. Step 2 said we are now going to focus on getting these terms to be a 0. And then this term to be a 0. So step 1, we keep working at it until we get both of those to be zeros. To get them to be zeros, I would not multiply by 0. You cannot multiply by 0, okay? But I can add a multiple of any other row. So since this is the first time we've done this, let me give you an example here. Thank you. If I were to, example, add row 1 to row 2, right now it'd be 3. That's not helpful. I want it to be 0. So think about what could I multiply this by so that when I add it here, we get a 0. Nope, because 0 plus 2 is 2. Negative 2, right? Negative 2 times 1 is negative 2. And then if I add that to the 2 that's already there, 0. Okay, so that's what I'm going to do. I'm going to take negative 2 times row 1, and I'm going to add it to row 2. So row 1 and row 3 are not changing. Row 2 is going to change. I'm going to take 2 times this number right here. And actually, let me show it in here. I'm going to take negative 2 times 1 and add it to the 2 that's there. 2 plus negative 2 is 0. Take negative 2 times negative 1 and add it to the number that's there. Negative 2 times negative 1 is 2. Plus 1 is 3. Take negative 2 times row 1. We get a negative 4. Negative 4 plus 2 is negative 2. And negative 2 times 9 is negative 2 plus, negative 18 plus 18 is 0. All right, again, let me double check my numbers here. Doing okay? All right, so remember now we are still on step 2, right? Step 2, we continue with this same column right here. Now I want this guy to be a 0. What can I do? Again, can't multiply by 0. Negative 1 times row 1, right? I've got a 1 here. If I were to multiply that by negative 1, it'd be a negative 1. Plus this would be 0. So I want their sum to be 0. So I'm going to do negative 1 times row 1 and add it to row 3. Okay, so let's do that again. Negative 1 times row 1, that'd be a negative 1 plus 1 is 0. Negative 1 times negative 1. Okay, negative 1 times negative 1 is 1, plus 2 is 3. Negative 1 times 2 is negative 2, plus negative 1 is negative 3. Negative 1 times 9 is negative 9, plus 6 is negative 3. How are we doing? We're doing okay? Yes? Okay. All right. Our next focus is, what are we on? Step 3? Step 3, I want this guy to be a 1. Okay, giving you some practical advice. Look at what we have here. I can actually avoid a fraction at this point. So we have 2 options. I could multiply this row by 1/3. If I do that, I would have 1. I would have negative 2/3 and I would have 0. We can do that. But I can avoid a fraction too. Does anyone see a way that I could like manipulate this to maybe avoid a fraction and still get towards that goal of getting that to be a 1? What do you see, Logan? Yes. Here's what I would avoid at this point. So that would accomplish the one part of it, but it would undo our process here. So be cautious at undoing what you've already accomplished. We don't want any of this to be undone. Guys, what if I were to flip these two rows? Would I be able to, can I do that? And then if I have all threes here and I get that first term to be a 1, will I have any fractions? No. So maybe that's an option we take. I know it's kind of an extra step, but I think it'll save us from having fractions in the long run. So I'm going to come up here and I'm going to just switch row 2 and row 3. And that doesn't undo anything. I still have that. One, 0, 0 in column 1, right? But now, if my focus is still on trying to get this to be a 1, now you guys understand what I just did is very optional. We absolutely could have just multiplied this by 1/3. It just does have a fraction. I just don't like fractions. So next, what I would do is now take row 2. I would say divide by 3, but there's no, you don't divide, you multiply by the reciprocal. So this is the same thing as dividing. I want to divide this by 3 to make it a 1. That's equivalent to multiplying by 1/3. We all okay with that? Okay. So what that means is I'm going to go through and take all of these times 1/3. And we get 0, 1, -1, -1. Okay, step 3 is accomplished. We got a 1 there. Move on to the 0 below it. Okay, so our next focus is finishing out that column. Okay, I put a little note up there. Only use row 2, not row 1. It may be tempting, but if you use row 1, it will undo our progress, okay? Because it would put something back in that first column, and we don't want that. So only use row 2. So let's look at row 2 and what we can do. Row 2 is here. I want this to be a 0, so focus on this number right here. I want to add these together to get 0, and it's currently a 3 and a 1, okay? So what should I multiply row 2 by? -3. -3 times that row 2, and I'm going to add it to that row 3. So again, we're going to go up here and say -3 times row 2. Put those together. Well, that's still 0. -3 times row 2 gives me that 0 that I wanted. Oops, I'm going to run out of room here. -3 times row 2. -3 times -1 is 3. Plus -2 is 1. Ooh, that kind of helps us out a lot, doesn't it? -3 times -1 is 3. Plus 0 is 3. And step, what are we on? 5? Step 5 said, get a 1 in the last spot of that diagonal. Well, we kind of looked out on this one. If it was any other number, I would at this point multiply by its reciprocal. We don't have to because it's already a 1. Let's pretend it was a 4. I would multiply row 3 by 1/4, right? Okay, questions so far? Okay, so as we look at our steps, we have now accomplished all of this. The last thing you're going to do is write that system and do back substitution to finish solving. So what does that look like at this point? If I translate this back into a system, these again are my coefficients of my variables. So we are looking at 1x minus 1y plus 2z equals 9 would be that top equation. My second equation would be 1y minus z equals -1. And our last equation would be 1z equals 3. And it's because of this that our solving becomes very easy at this point. I now do back substitution. And so I take the fact that z equals 3 and we sub that in for the z in the equation above it. So I have y minus, z, which means y equals 2. And now I have 2 out of the 3 variables. Z is 3, y is 2. And I go back up to my last equation and I take both of these answers and we sub them into the top equation. That says x minus y, which we now know is 2, plus 2 times z, which we know is 3, equals 9. Solve for x. Let's see, that'd be -2 plus 6. -2 plus 6 is 4, which means x equals 5. In order of alphabet, x, y, z. Okay. I'm not going to ask you to do a lot. I'm going to ask you to do them really well. Okay. You need to go slow. You need to make sure that you double check your mental math. I will tell you right now that all of our answers turn out nice at the end. So if you are getting something like 15, 60 seconds, I don't know, something went wrong. Okay. I think the ugliest number I've seen happen is 1/6. And that's like extra ugly compared to most of our answers turn out to be like whole numbers, okay? Any questions for me on this process? All right.